No, that's for tomorrow, same time.
I'll probably give more examples again tomorrow, but
So, we
you,
won't
well, you
have
really
those
don't really
cards,
need them
yeah.
because it's the same thing as what we're doing today.
9.
Okay, what we're doing is called verifying trig identities. And that's what you're doing on 14 through 26. To verify a trig identity, it says you gotta make one side look like the other side. And again, you may pick the right side and your neighbor may pick the left side. It doesn't matter which side you choose to make look like the other side. And again, I can do it many different ways. So, and then I did give you a couple of new formulas. You may want to add that to your trig information sheet. I don't remember if I put that on there already. Sine of a negative angle is also a negative of that sine of that same angle. And cosine of a negative angle is a positive cosine of that angle. I don't think I remember to put that on there, so you might want to add that somewhere on that sheet so you have that. What?
Which part was it?
So cosine positive?
The note where it
Yeah, it was negative.
Oh, note that, I'd say put it on your information sheet. By the time we finish with this information sheet, you're going to have everything you need on it for the chapter test, pretty much practice. Okay, we are going to make one side look like the others. Everybody understand what we're at this point? So instead of simplifying a single trig, and you don't know what it looks like, you know what your goal is. Okay, so my first example is this one. Is everybody ready to start? You don't have to write these all down at once. I'm just going to do one at a time. Yes, Delaney?
It says sine and then has parentheses negative x equals negative sine.
Yes.
The second one's supposed to say negative cosine.
No,
Okay.
it's supposed to be positive cosine. And the reason for that is a negative angle puts the sine in the fourth quadrant, which makes it negative. And a negative angle puts the cosine in the fourth quadrant, which the cosine is positive in the fourth quadrant. So that's why that works. So that's just something you want to note. Okay, you guys ready? Okay, so my first example for verify. Now there's two sections this time. The verify section is the 14 to 26. The 30, 32, 36 is the numerical value in a one trig function, which is what we've been doing, except it's going to be equal to a number. Okay, verify. My first example says 1 minus cosine squared of x over cotangent squared of x equals cosine squared. Now, do you notice the difference in what you've been working with? What do we have different?
Yep, equal.
We have an equal sign. And I said you can either make the left side look like the right side or the right side look like the left side. Usually how I decide which side I'm going to work with is I'm going to pick the side that has the most stuff on it. Because it's easier to make something bigger become smaller than it is to enlarge. Okay? Does everybody follow my motive there? Okay, so what would you think you want to do on the left side, since that's the one I'd want to choose to work with?
Cotangent squared into cosine squared of x over sine squared of x.
Cosine squared of x over sine squared of x? Everybody agree with that? The 8 identities, which those, I hope you're getting them down pat. Remember, when it comes test time, that's the first question on the test. You got to be able to name them. Okay, now, doesn't this mean to divide?
Yes.
So that's cosine of squared over 1. When you divide, you invert and multiply. This stayed over 1. This fraction, you found its reciprocal and you're multiplying. So what happens with that fraction?
Sine. Would it be secant squared?
Those would cancel.
Those cancel. So you have 1 minus sine squared. We want 1 minus sine squared is cosine squared. Look at that first of the 8 identities. If I were to solve for sine squared, or if I had to solve for cosine squared, I'd subtract sine squared, right? So 1 minus sine squared is cosine squared. And you've just done the process called verification. You proved that this equals that. Everybody follow what we did there? Do you see it's a little different than what you've been doing? The only difference is now you know what you want it to look like.
Yeah.
You have a colon. Next example. And you guys already have this down, so I'm gonna move up and use this area. So this would be example 2, right? Okay, which side do you think you wanna work with?
Left side?
Do you want the left or the right?
Is that side?
This is sine of x minus 1 and sine of x plus 1.
Okay.
Is everybody thinking the
Left side.
left side? Why?
There's more to it.
More to it. Okay, now, what do you think you would do on the left side?
Common denominator.
Which you could also do the butterfly then, right? Okay, does everybody agree with the butterfly?
Yeah.
Take a brief second here, we'll show Becky my butterfly. To add or subtract fractions, you do a process called butterfly. It only works if you have two fractions and they're in addition or subtraction. The first wing is 12, the second wing is 15, and then you multiply the two denominators, so 3 times 6 is 18, so that's 27/18, which you reduce by 9, and it works the same way as getting a common denominator. It's just a different method for finding a common denominator, which you may want to use in trig. Sometimes it's easier. So we can use the butterflies, everybody concur?
Yeah.
Okay, so what's my first wing gonna be?
Sine of x plus 1.
Now my second wing this is a -1 times that, right?
Yeah.
So it's gonna be
A negative sine
plus.
plus 1 over, what's the rest of the butterfly? You multiply the two denominators. And right now I'm just gonna, let's see, what would I get if I multiply those? It would be first times first.
Yeah.
And the inner and outer is gonna cancel, right? It'd be FOIL because they're binomials times a binomial. And it'd be minus 1. Okay? Now, what happens on top? So the signs go to 0.
There's 2.
1 plus 1 is 2, so look, we're getting what we need. We need a 2.
Oh my gosh.
Why does that do?
1 plus 1.
What if we did it using the
So where does the signs go? Oh, they cancel?
Yeah, sine minus sine goes to 0. Okay, we're almost there.
sine squared minus 1 is cosine squared?
Technically not. 1 minus sine squared is cosine squared, right?
Yes.
Yeah.
I mean, 1 minus sine squared is cosine squared.
Yeah.
But if I multiply by -1, doesn't it make it that?
Yeah.
Does everybody follow what I'm saying?
Yeah.
And that's legal as long as you got opposites of each other. So this is really cosine. One minus sine squared, remember, you can manipulate the Pythagorean ones, is cosine squared. But I'd have to multiply by -1 if I wanted to match that because it's the opposite or the opposite of it, like 2 and a -2 or 3 and a -3. So now this gives me a -2 over cosine squared. And what happens when you have cosine?
How do we get the -2?
I just moved the negative up to the top,
Okay.
so I just moved my negative. What do we know 1 over cosine is? Secant. And since it's cosine squared, the answer would be
2 secants?
secant squared. Yeah. Okay, did everybody follow what we got there?
Okay, right before the final one, did you have 2 over negative cosine squared of x? Is that what that is?
Yep. This was 2 over negative was right here. Then I just moved the negative up with the 2. And I know when I have cosine on the bottom, that's secant. So that was where that last step went to.
Okay.
That makes a lot more sense.
Why did you I understand that sine squared.
Because this is sine squared minus one, it's not the same thing as one minus sine squared. It's the opposite of it, so that's why you have to
Oh,
multiply by
okay.
-1. Okay, example 3. If you get this one down, then you don't need to write down any others. I think 3 would be good. If you wanna write more down, you can. But if you soak it in, sometimes that helps too. Okay, which side do you think you want? Left, okay? On the left, somebody tell me what they think they'd wanna do.
Distribute,
Secant squared.
You could do that.
Or the 1 minus cosine squared.
That's the way I'd go.
Yeah,
1 minus cosine squared is
sine squared.
sine squared. Just, you could have distributed and you got there. Remember I said there's many ways to get there. So I'm not discouraging you from going your avenue, I'm just saying, I saw that one might be the fastest. Now, what's another way of saying secant squared? 1 over cosine? And I always, whenever I'm verifying, I look at the other side to see, I know what I wanna go to. I've got the sine squared, what do I need technically? I need a cosine squared on the bottom. And isn't that what a secant is?
Why is it minus the sine squared?
It's not.
Oh, it's minus, okay.
Now what do I get? Tangent squared, because it's sine squared over, and I'll go ahead and write that step, if anybody needs it. Example 4. And again, if you want to write it down, you can, or if you just want to absorb it.
Is that?
That's cosine, parentheses, secant minus cosine equals sine squared. Now, which side? Left, again, there's more on the left side. That's not always the case, but I guess I just made all my examples left-sided. Now, what do we do? What do you want to do?
Distribute. I would change secant to 1 over cosine first.
Okay, you could do that. Well, everything's cosine, so now couldn't I just distribute? Well, what's cosine times 1 over cosine?
1.
And what's cosine times cosine? You got it, Richard. Now, if you would have distributed to begin with, cosine times secant, don't we know that when you multiply reciprocals, you get 1?
Yeah,
That would have worked too.
it would have been exactly the same.
You got it, exactly the same, it's just one step faster, would be basically it. Okay, is everybody on example 4? Okay. Which side? Left, what do we want it to make it left look like? We want it to become tangent. Okay, now, any idea what we want to do? That's secant plus 1 times cosecant minus cotangent.
Can we put them all in terms of sine cosine?
Okay, so Richard, tell me how to change secant.
1 over cosine
Okay,
plus 1.
I'll do that to give you the hint. What do you do for cosecant?
It'd be like sine
1 over sine.
minus cosine of sine.
Okay, so I gave the hint as to what I do on this one. What was that hint?
Butterfly.
Butterfly. So what's my first wing? Becky, we'll have you try it since you.
1
Okay, second wing.
would be cosine.
And And now what's the two denominators times each other? Cosine. Now, this one, did you guys notice they're already the same denominator?
Mm-hmm.
So we don't need to do the butterfly, all we gotta do is put them over the same denominator, which would be 1 minus cosine over sine.
So you have to find common denominator.
No, we don't need to find a common denominator, they're already the same.
Okay.
Or you say, now we're ready to multiply, what's the rules for multiplication of fractions?
Straight across.
Straight across. Okay, so on top, how am I gonna multiply 1 plus cosine times 1 minus
So
cosine?
you do 1 minus cosine squared.
You just foiled, and the inner and outer cancel, don't they?
Yeah.
And on the bottom, we've got cosine times sine.
That's sine squared on the top.
1 minus cosine squared is sine squared.
And then one of the signs would cancel.
One of the signs is gonna cancel the one on top,
That's what the sine and cosine.
which is
Tangent.
tangent. Okay, so, what were those problems again? 14 to 26 even? Every one of those you're gonna verify, make one side look like the other side. Now, 32, 30, and 36, you're making a numerical value become one. Oh, I wrote 36, it's 34, isn't it?
When I looked at that one, like, maybe it's
No, it's supposed to be 34. I knew I thought I did them in order. A numerical value of one trig function. So that means you've got to work with getting to one trig function, which hadn't that what we've been doing, and then it's going to be equal to a number.
What page is it?
434. See, I've already got Friday's assignment up, but you can always look over here, and that's the assignment we're doing today, because that's, yeah, 4th hours. Dave on it.
So tomorrow we're doing the same thing that we did today?
Yes.
Okay.
We're just verifying them, we aren't doing the numerical value. Because it's really essentially doing the same thing,
But, simpler.
yeah, just verify.
Is that all yet?
okay.
Not yet, we got 30, 32, and 34 to go over.
Pages 38.
Oh, okay.
I got 2 examples there. One example ought to do it for you,
What are we doing on these ones?
verify,
More.
they're all verified. In other words, what we just got finished going over, Mason. Okay, what would we do on this one? We want to try to get to a single trig.
Would you make
What could I change cosecant to?
1 over sine.
What could you change cotangent to?
Cosine.
What do you do when you divide with fractions?
Inverse multiply fractions.
So the reciprocal of that would be sine over, sine of the sines cancel. What's 1 over cosine?
That would be C.
There's our answer. We got a single trig equal to a numerical value, which is what you're trying to do on 30, 32, and 34. That's it. A single trig equal to a numerical value. Which is, this is really just like what we've been doing. Okay? I have one more example there, example 2. Oh, can you guys see it okay and I won't rewrite it?
Yes.
Okay, what do we want to do?
Put it in terms of sine.
Sines and cosines, again, anytime you got problems, what should you do? Put it in terms of
Sine cosine.
sines and cosines.
Unless it's just like a shortcut, otherwise.
Yeah. Well, I do notice this though, 1 over cotangent's tangent, right?
Yeah.
So couldn't I just go ahead and say sine over cosine? That saves me a step. Okay, what's secant change to? And what's cosecant change to? So don't I have to, so this one, forget this right now, but this means to divide, and when you divide you, so that would be times sine over 1? Does everybody agree there? Oh, well, I think I can go ahead and go back, that's tangent. What's that?
Sine or cosine is tangent.
Which is tangent. What's tangent minus tangent?
Zero.
We we didn't even have to mess with that side, it was already the single trig, it's just this side ended up being numerical. Okay, so it's gonna be a single trig equal to a numerical number. So that's 30, 32, and 34. Yeah, you guys, questions?
Or cosine.
Cosine.
It was equal to a cosine.
Okay.
Okay, now you can get the video and, let's see, what are we doing? 14, 16, 28, all the way to 26 even, and then 30, 32, and 34. And I would like to see first couple